Here we have the graph of the age-adjusted trends in prevalence of high LDL cholesterol. The blue line represents high cholesterol. It's the percentage of people with a high cholesterol on given years. So our x-axis are the given years, and our y-axis is a percentage. So 59% of these people had a high cholesterol between 1976 and 1980. 42% had a high cholesterol between 1988 and 1994. And it maintained at 42% in 2001 to 2004 and 2007 to 2010. The green line represents the people that met less than a 10% of kilocalories from saturated fats per day. So this is a different meaning. This is not your cholesterol. Instead, this is your met less than 10% of kilocalories from saturated fats per day. So 25% of the people in this time period, 41 in this time period, and then 33 in this time period, and 27 in this time period. So what we want to do is we want to do some linear regression from this information. Okay, so let's take a look at what Jacqueline did. So Jacqueline started with the blue line. So let's pick blue, and she took a percentage of 59% in 1976 and took that point. So her x value is 1976, and her y value, the height, is 59%. And then she took her next point at 42%. So 42%, that's the y value, and the x value is the starting date of 2007. So she said her starting year, 2007. That's her x value on the x-axis, and the percentage, and that year is 42%. And then she said, I'm going to calculate my slope, which is m. And the slope is the ratio of the change in y values here from 59 to 42 over the change in x values from 1976 to 2007. So what we have is the numerator is the change in y, and the denominator is the change in x. Well, the change in y, our y values are 59 and 42, so we'd say 59 minus 42 in the numerator, and then in the denominator we would have 1976 minus 2007. And this gives us a negative 1.03, and Jacqueline got a positive slope, but this is actually a negative slope, because although here the numerator is positive, the denominator is negative. And I believe she took 42 minus 59 in 2007 minus 1976, which is fine, but the slope will still be negative. And in her next step, Jacqueline was correct when she used point slope form. Y minus a y value from our point is equal to the slope times x minus the x value from our point. So we need to replace the y1 and the x1 with one of our points, and Jacqueline used 1976.59. And then we need to replace m with our slope, which is the negative 1.03, so let's do that. So it would be y minus our y value, and our y value is 59, is equal to our slope, which is a negative 1.03 times x minus our x value, which is 1976. And from this point, let's change the subtraction to add the opposite. So that's a negative 59, and that becomes a negative 1976. And we're going to distribute this negative 1.03 to the x and then to the negative 1976, and so we end up with y plus a negative 59 is equal to a negative 1.03x plus, and a negative times a negative is a positive, and 1.03 times 1976 is 2035, and 28.28. Okay. At this point, we could leave this in slope-intercept form, and that would be, we'd add 59 to both sides and get y is equal to a negative 1.03x plus, now we're adding 59 to both sides, so we're going to add 59 to 2035.28, and I'm doing this on my calculator, and we would get 2094 and 28. So when you're working on finding the linear regression equation for the green line, you will follow the same process.